Hi students, in last class we are discussed about data compression and how we are going to be do the data compression, and we are discuss these topics, and especially in data compression especially I am going to take the 4 topics, and in these 4 topics I am going to be take the such things. So especially in this such things I am going to be check the data. So while coming to here in this checking the data, so here I am going to be make the certain steps. So whenever you are going to be make the certain steps, that means you have to be convert the data into one format to another format. So this conversion we can call as the data compression. So in this we are going to be take the text conversion, image conversion, audio conversion and video conversion we are going to be make. And coming to here the continuation. So today topic is techniques of data compression. There are 3 important techniques of data compression. So especially if you are able to convert the data compression, you are having the 3 techniques. First one is the basic technique, number 2 statistical technique, third one dictionary method. So what is meant by basic technique? So in this basic technique which is going to be used only in the past. So especially in the past I am going to take these things. So especially in these things I am going to take the data here, and in this data I am going to be observe the each and everything. And coming to here, especially in this technique, we are going to be take the run length. So what is the run length of there? So based on that run length, I am going to be encode the video, and in this encoding it is going to be moved to the front encoding. So here it is going to move to the front encoding. So based on the run length encoding is going to comes in a basic technique. So these technique which have been used in the past. So next one comes to the run length encoding. So what is meant by run length encoding? So especially in this, the basic idea behind this approach to data compression is this: if a data item occurs n consecutive items n consecutive times in the input stream, replace the n occurrences with a single pair. So here it is going to be take the compression part, and especially in this compression it is going to be take the single pair, and which is going to comes to the consecutive occurrence. So here it is going to be take the consecutive occurrences. So here it is going to comes to the single pair. Pair means 2. N consecutive occurrence. So here I am going to taking the data item, and based on this data item called the run length. So especially based on this run length I am going to be do the encoding. So this type of encoding we can implement in a scenario here. So especially in this scenario we have to be observe the all of these things in the concept here. So especially in this concept you have to be observe the all of these things, and in this the data item are called the run length. So it's going to depend on run length, and this approach we can call as the RLE. So RLE comes to the run length encoding. So especially this run length encoding I am going to be used for audio compression and video compression. Especially in these 2 elements, these 2 is going to be based on the audio or video encoding is going to be come. So here I am going to be take the such things especially in this run length encoding. So here it is going to be take the concept which is going to be come to here. So in this I am going to taking the run length encoding. So in this run length encoding I am going to be take these things so which you are going to be implement, and these things is going to comes in a similar manner, and these things you have to be observed in a best way, and these are comes to the run length encoding. Next, second one, move to front coding. So the basic idea of this method to maintain alphabet A symbols a list. So here alphabets comes to the here I am going to maintain the alphabet A, and next comes to the I am going to take in the symbols, and in this symbols I am going to be taking a list, and in this list the frequently, so based on that frequently some symbols are there, and these symbols is going to be located in the front. So based on the symbol we are going to be make the encoding process. A symbol A is encoded has a number of symbols, and these symbols that preside in it in this list, and in this list A equal to THES, and the next symbol in the input stream is to be encoded E, and based on that the encoding is going to be done by the two symbols. So it is based on these two symbols it is going to take the data, and in this data it is going to be stream and is going to be encoded, and whenever it is going to be encoded it is going to comes to the 2, and it is preceded comes to the two symbols, and these things I have to be take, and here A comes to the ETHS. So in this it is going to be moved to the front step, reflects the hope, so it's going to comes to the E, and which is going to comes to the input stream, and it is going to be read many times. So based on that common symbol it's going to be read, and it will be use the conversion. So next one comes to the Hoffman coding. So especially in the data compression we are going to be use the Hoffman coding. So in this method it is going to be starts building a list of alphabet symbols. So here I am going to be build a list of alphabet symbols. So here it is the symbols I am going to be take in a descending order, and especially in this descending order I am going to be take the probabilities, and whenever I am going to take the probabilities, and here it is going to be construct a tree and with a symbol, and is going to be take the every leaf from bottom up, and the character string is going to be transmitted into first analyzed, and the character types, so which is going to become relatively determined and is going to be take here, and especially in this Hoffman code, so which we can call as the binary tree. So what is the binary tree? The binary tree which is going to comes to the values of 0 and 1, so those we can call, those codes we can call as the binary. And in this Hoffman code, whatever may be the tree I am going to be taking, especially the branches I am going to be assigning 0 and 1, and in this branch is going to be divides binary value 0 and 1, and is going to comes to the assigned to the each branch, is going to be assigned to the each branch. So here comes to the binary comes to the 0. So here how we have to be assigned. So left branch I am going to be assigned to the 0, and right branch I am going to be assigned the 1 value. So these two things I am going to be take in this scenario. So especially left comes to the 1, and right left comes to the 0, and right comes to the 1. So here if we are going to be take here the binary code will becomes like this. So here I am going to be taking the value 0 1, I am going to be taking these values, so based on 0 1, and here comes to the root, and here comes to the branch, and left I am going to be not assigning any branch here. Rn like that I am going to be taking. Rn comes to the root node, and Bn we can call as a branch node, and Ln we can call as a leaf node. And in this root node, first in a tree we are going to be give the root value. So here I am going to be mentioning the root name comes to the Rn. So branch comes to the left side 0, and right side 1 I am going to be taking. So next for this branch again I am going to be taken the another tree. So here comes to the left comes to 0, right comes to the 1, again one more branch comes to the 0 1. So here there are no branches here, so assign that this empty space we can call as the leaf node. So this leaf node comes to the A, this leaf node comes to the B, and this leaf node comes to the C. So like that the values we are going to take. So comes to the A equal to the root value comes to the 1, and B is going to comes to the 0 and 1, and C comes to the like that the branches is going to comes to the 0 0 1, and D comes to the 0 0 0. So like that it is going to become. So here A equal to 1, B comes to the 0 1, so it is going to comes to the and next so here 0 and 1, C comes to the 0 0 1, and next comes to the 3 zeros. So like this we are going to prepare the Hoffman coding. So in this Hoffman coding, if you are going to be observed, so most probably cases I am going to be take the like this the root structure only. So in this root structure we are going to be assigned, that means we have to create a tree, we have to be assigned the root, branches and leaf nodes. So after that whatever may be the values will be there, you have to arrange left comes to 0, right comes to the 1, and next you have to be take the certain values and you have to be enter in normally. So this is comes to the Hoffman code. So next topic I am going to the arithmetic coding. So in this method the stream, the input stream is read symbol and appends more to the code, and each same time. So whenever it is going to be read the symbol at the same time. So a symbol input is going to be processed. So in this it is going to take the input and it is going to be processed. So in this to understand in this method, so I am going to be imagine the resulting code. So what is the resulting code? Especially the resulting code comes to the here 0 and 1. So here resulting code has a number in the range I am going to be taking 0 comma 1. So here 0 comma 1, that is the range of real numbers from 0 to 1 and not including the 1. The first step is to calculate. So here I am going to take in the first step. So in this first step it is going to be calculate the least estimate frequency. So this frequency which is going to be occurrence on the symbol, that I am going to be take the data here. And these things you have to be observed while in this scenario you have to be take the data. And next one comes to the LZ77 sliding window. So coming to here LZ77 and LZ78, these two we can call as lossless data compression. What is mean by lossless data compression? So especially in this lossless data compression, the data is going to compress without losing the original part of the data. So these data compression algorithms which are published in the papers, Abraham Lempel and Jacob Ziv. So these algorithms is going to be invented by these persons and is published in a paper that comes to the in the year 1977. So LZ algorithm which is implemented in the year 1977 and LZ78 is implemented in the year 1978. So these algorithms we can which comes to the lossless data compression algorithm. So in this data compression algorithm it comes in lossless. So these things is going to be take in the data compression algorithm. So in this we can also name as LZ1 and LZ2 also we can call them. They are both dictionary coders. So here these both we can call as the dictionary coders. So the coding part is available in the dictionary, and in this dictionary it is going to comes to the coding part. So that's why they are both dictionary coders. Comes to the LZ77. Comes to the sliding window. So this we can call as a sliding window compression algorithm. LZ77 is the sliding window compression algorithm. The main idea of this method is to use part previously seen input stream as the dictionary. So here the main idea, especially if you are going to be implement this method, is to use previously seen input stream. So on the dictionary. So whatever may be the input stream, the data we are going to be taking, that we have to be observed, and whenever we are going to be observing the data, and we have to be take them, and after taking them we have to be encode, and we have to be maintain a window based on the input stream. So coming to here in this, if you want to make the streaming service, you have to be observe all of these things. And especially in this, if you are going to be able to maintain the window, first you have to be take the input stream. So whenever you are going to take the input stream, so here it is going to comes to the shift, and the input in that window, which is going to comes to the left to right, which is going to comes to the left to right, and the symbols is going to be encoded in a best way, and is going to be encoded in a best way. And these things you have to be observed in taking the encoding part, and such things you have to be observed. And when you are going to be observe these things, you have to be take the data here, and in this data you have to be take the each and everything. So everything is going to comes to the to maintain the data here, and in this data is going to comes to the and is going to gives the best output for you. So here the best output you are going to be see in single manner. So in this single manner you are going to get the thing, and you are going to get the data, the compression, which is going to comes in best way. And these things you have to be observed in this data compression algorithm. And especially in this data compression algorithm, you have to be observe the all of these steps. And without these steps, you are not able to do the experiment part. So in this each and every experiment, you have to be maintain all of these things. So especially in this the video encoding part, which is going to be take from left to right, and is going to take the videos from encoding the part, is going to be especially comes to the left to right. So in this I am going to be taking the sliding window algorithm. And coming to here, the main idea of this method is to use part previously seen. So whatever may be the previous scene, the input will be there, so that we have to be take in our algorithms, and after that the compression of the window is going to be comes in two ways. Especially in two ways, is going to be move left and right, and in this left and right it is going to be take the data, and is going to comes in a similar manner. And these things we have to be take in our thing, and these things we have to be observed while in the conversion part of the data. So in this conversion you have to be take all of these things, and these things you have to be implement in a data here, and these things you have to be implement in a best way, and these things you have to be observed in a similar manner, and these things you have to be take in a better thing. So these are the comes to the encoding. Source entropy and hybrid coding. So what is meant by source and encoding. So here I am going to be taking the data especially in the part of the encoding. So here encoding part I am going to be take the data here. So in this data, so which is going to be converted especially in the compression method. So in this compression method I am going to be taking the lossless encoding. So what is meant by lossless encoding? So especially in this data, the encoding method, so which I am going to be implemented, I am going to be take the data in a better way, and in this better way I am going to be convert the data according to the choice. So here in this choice I am going to be encoding the data with lossless encoding. So whenever you are going to take the lossless encoding, I am going to taking the data. So in this data we have to be observe the all of these things. In this we have to take all of these things when it comes to the encoding part. So these things you have to be observed in encoding way, and these things you have to be observed in encode. Next, media specific characteristics. So here in this you have to specify based on the media. So the media is going to comes to the, and it's going to give the some specific characters. In this specific characters is going to be take the data, and in this data which is going to comes to the is going to specify the thing, and in this specify the thing is going to be implemented. We are going to take the data here. So in this data it is going to comes to the which is going to comes to the based on characteristics, and in this characteristics it is going to be take the data, and it is going to comes in a similar way, and it is going to comes in a similar way, and these things you have to be observed. So this is comes to the we have to be take the data here. So in this data we have to be take the effect. So in this effect I am going to take, and these things I have to be observed. Next one, so data sequence is going to be taken on the simple part. So here I am going to take the data sequence part. So whenever I am going to take the data sequence, it is going to become, and it's going to be take the data, and it is going to comes to the in implementation part, and in this implementation it is going to comes to the one by one. So especially in this is going to be take the Hoffman encoding. So in this Hoffman encoding, so these things is going to be observe the data here. So Hoffman encoding already you know. So we are going to be take the data based on the encoding part. So whenever we are going to make the encoding, we are going to be take the conversion. So especially the Hoffman encoding we are going to take in runtime length encoding only. So in this runtime length encoding is going to be take the data, and in this data which is going to comes to the digital sequence. So here the data is going to comes to the based on a digital sequence. So in this digital sequence the data is going to become, and in this data it is going to take 1 2 3 4 5 6 and 7 8 and like this the steps we are going to be take in easy manner. And coming to here decompression process. So especially in this decompression, so it's going to be generates the data completely. So next one, source encoding. So coming to the source encoding, this is also comes to the lossy encoding. So in this it is going to be lose the some length of the data, and whenever it is going to be lose the length of the data, and it's going to be take here. And especially in this source encoding, so first encoding the part is going to be depending on the source. So first we have to understand the source, and after the source we have to be take the data, and whenever you are going to take the data, here you have to be observe these certain steps, and in these certain steps you have to be encode the data with by taking the some methods, and when you are going to be follow these methods, sometimes you are going to be lose the data also. So So in this loosey encoding, we are going to be take the some modulation and techniques we are going to be follow. So when we are going to be follow the modules or techniques, such times the data is going to be loss for you. So in this data loss, it is going to consider the steps it is going to be taken, and here the steps is going to becomes in a similar manner. So in similar manner, it is going to be take the data and is going to be take the completion of your data only. So in this completion of data, it's going to be take the certain steps, and in this certain steps is going to be take the best method. So in this best method, I am going to be taking the data. So in this data, I am going to be make these things I have to be implement in my execution part of the data, and these things I have to be take in a similar manner, and in the similar manner I am going to be take the all of these things. So especially in this account, I am going to be observe on the semantics of the data. So in this semantics of the data is going to be take the certain steps, and in these certain steps we have to be take the compression degree. So at how much percentage you want to compress the image, and these things you have to be take in degree of compression, and this degree of compression is going to be depend on the data content. What is the data? The data content is going to depend on comes to the whether that is audio file or video file or image file or text file. So based on that, it is going to depend on the data. So whenever it is going to depend on the data, we are going to make the compression, and here we are going to make the certain degree. That degree means I am going to mention in the percentage form. So whenever the percentage form is going to become, so based on that percentage, the data will be encoded here. And in this content prediction, I am going to be following the technique. This technique I am going to be called as DPCM, and which comes to the delta modulation. This we can call as DPCM or delta modulation. Next, hybrid coding. So comes to the user by most multimedia system. So hybrid coding is going to be used by the multimedia systems. So in this, it is going to combine the source encoding part. So whenever it's going to combine the source encoding, it's going to take the two things. So coming to here, in sometimes while I'm going to make the conversion, I'm going to take the targeted that means the compression file, and after that I'm going to be take the source data also. So whenever I'm going to take the source data, here it is going to comes in the form of the percentage. Here it is going to comes in the form of percentage. So whenever it is going to comes in the form of the percentage, is going to be take the source encoding. So based on that source, if you are going to make the encoding, this we can call as a hybrid encoding. So most probably in our multimedia system, we can follow the hybrid encoding only. So in this, I am going to combine the entropy, and in this entropy I am going to be take the source ending. So in this source ending, I am going to be take the JPG H263 DVI, and like that I am going to be take the data. So these things I have to be taken JPG H263 DVI, RTV and PLV, and MPG1, MPG2 and MPG4, and these codings I have to take for conversion the process, and conversion I am going to be take. So especially the encoding part, especially in the images, videos, I am going to be taking the video codec that is going to be contain H264 and X264, or I am going to take H265. So these video codecs are advanced, and these video codecs I am going to be used in a similar way. And this is comes to the your today class comes to the techniques of data compression. In next class we will discuss major steps of data compression, and I am sending the notes. Please read it. We will meet in next class with another topic. Until then, take care.